So to find y prime for this first one, we're going to use a product rule. And our two parts of the product will be this part and this part. So y prime will equal 21 out front. And let's use some parentheses. So first I leave the first part alone, x cubed. And I take the derivative of square root of x, or x to the 1/2, which is 1/2 x to the minus 1/2. Plus, now I'll take the derivative of x cubed, which is 3x squared, times the derivative of square root of x. We're leaving that part alone. Now I did say to simplify, so we have 21. And we're going to have 1/2 x cubed times x to the minus 1/2 will be x to the 5/2 plus 3 x squared times x to the 1/2 will also be x to the 5/2. So we have 21. We have like terms in here because they're both x to the 5/2. So times, this will be 6 halves. So we have 7 halves x to the 5/2. Multiplying that 21 through, we have 147 over 2 x to the 5/2 is our simplified answer. In this next one, again, we're going to have a product rule. First thing I would do is rewrite the top. We'll leave the x over 2.6, or you could write it as 1 over 2.6 times x, plus 2.6 x to the negative 1 times x squared plus 1. Now again, this will be a product rule. So we're going to have y prime equals, let's take the derivative of the first part. So the derivative of x over 2.6 is just 1 over 2.6 because it's linear. Derivative of x is 1, and we have to keep the constant. Now, plus, first thing we'll do, we got a power rule for the second part. Bring the negative 1 down, it's negative 2.6x, decrease the power by 1 to the negative 2. Put that in parentheses, and we're leaving the other part alone, x squared plus 1. Plus, now we'll leave the first part alone, x over 2.6 plus 2.6x to the negative 1, derivative of the second part, which is 2x. There's not going to be a ton of simplifying we can do, so we will do just a little bit here. 1 over 2.6 minus 2.6 over x squared times x squared plus 1 plus, now I'm going to distribute this 2x, so then I'll have a 2x squared over 2.6 plus 2x, sorry, that'll get multiplied by that 2.6 over x. Those x's will cancel. There's not a lot we can do with this first part, so I'm not going to mess with it too much right now. I'm just going to kind of leave it. 1 over 2.6 minus 2.6 over x squared times x squared plus 1 plus 2x squared over 2.6 plus 5.2. And 3, first thing we're going to do is rewrite it again. So square root of x plus 2 times square root of x plus 4x to the minus 2. Another product rule. So y prime equals derivative of the first part. So the derivative of square root of x is 1/2 x to the negative 1/2. Derivative of 2 is 0. So that first part is done. And this gets multiplied. Let's go ahead and write it as x to the 1/2 plus 4x to the minus 2, because we're leaving that part alone. Now plus, now we're going to take the derivative of this part. The square root of x is 1/2 x to the minus 1/2. Plus, now we got a power rule, bring the negative 2 down, and we got a negative 8x to the negative 3. Now we leave the second part alone, which is square root of x plus 2. And we have our derivative. Since we didn't want us to simplify or expand, we'll just stop there. Alright, in this one we have a quotient, so we're going to use quotient rule. So we write it as 6x to the 1/2 plus 3 over x to the 1/2 plus 2. Now applying our quotient rule, we are going to have the denominator left alone, so x to the 1/2 plus 2 times the derivative of the numerator. So using that power rule, the 1/2 comes down, we get 1/2 times 6. So 3x, decrease the power by 1 to the negative 1/2. Derivative of 3 is 0, so we don't put that in there. Now remember, quotient rule is minus. Now we need to leave the numerator alone. So 6x to the 1/2 plus 3 times, now the derivative of that denominator is, we got that x to the 1/2 piece, that's going to be 1/2 x to the minus 1/2 plus 0, because the derivative of 2 is 0. All over x to the 1/2 plus 2 squared. Now what they had asked us to find was the derivative at x equals 4, so we would plug 4 in for our x's and evaluate. You don't need to simplify to be able to evaluate it at 4. Okay, last one we're going to look at is a revenue problem. You're given the price of oil in dollars per barrel and the quantity of oil in millions of barrels per day. And so if we want to find the daily oil revenue, we'll call it R of t. It will just be the product of these two functions. So take P of t and multiply it with Q of t. And that'll be your answer for the revenue. For the rate of change in the revenue, we want R prime of t. This is going to be a product rule. So what we'll do is we'll take the derivative of the first, so P prime of t, so you would take the derivative of your P of t, times Q of t, so we're leaving Q of t alone this first time, plus now we'll take the derivative of Q of t, so Q prime of t, times P of t left alone. So it'll just be our product rule. I'm not going to work this one out here, but I just want to go through the steps that you're going to do to find your daily oil revenue and your rate of change functions.